Hello students, in continuation to the series of lecture, this is part 3 of functions. In this part, we'll discuss about recursive function, how we implement recursion in Python programming using user-defined functions. So here is an example of a simple example that we already taken to find factorial of a number. You know that in any case, whenever we apply recursion, we need to mention one base condition at which we need to break. So that base condition in case of finding factorial would be at when we try to find the factorial of 0. At that point we have to terminate, otherwise we'll call that function again in the definition recursively. That's obviously the meaning of recursion, that the function calls itself. So as usual, we are starting from def keyword. This def keyword after the name of the function, number argument for which we want to find out the factorial. So at that point of time, if n is 0, in that case we'll return 1, otherwise we'll return n times the factor of n minus 1. That means this function is again called, it goes to the definition, again check the value of n. If it is 0, return 1, otherwise keep on calling itself. So this way, if you are trying to find out the factorial of 5, it will be converted to this particular sentence, like 5 into calling the function with value 4, because 4 is not 0. So again it will be converted this way, 5 into 4 and then factorial of 3 till we get 0, and when we'll get 0, we'll have this one value returned, and then this reverse multiplication will happen through stack, and finally we'll get the answer. I hope it's clear. If you want to see the implementation, we can demonstrate this implementation of recursion. For example, the same problem I am taking here. We have to start with def, and in def, fact is the name given to this function. Now, what is the parameter we need to pass? Let's say num. How will define? So as you can see, whenever I press colon, it is generating some space, and after that space only we need to write the code. So if num is 0, whatever the value of num is there, if it is 0, then we need to return what? 1. Okay, else we need to start the recursion. So how we'll start the recursion? That in that case we need to return num multiply by, call the function again with one lesser value. So num minus 1. For this value we'll call this function. Okay, in this way it will complete the definition, and after that we can call this function with some value. For example, if we call the function inside the print fact for value 3, so this fact will be called for 3 value, num is not 0, so it will call in this part. So that theoretical discussion will also follow in this implementation. Let us check the output for this. Before that we need to save this. So after saving it, if we execute, the output you can see here is 6. So this is how we apply recursion. We can take other examples as well for recursion. For example, we have to write a function, recursive function, to calculate exponent, where 2 parameters would be passed. One is base and another is the power. So like 2 raised to power 5 or 3 raised to power 9, for any number this function should be written, and that too using recursion. So what should be the base condition in this case? Basic condition at which we have to terminate. When the power is 0, then we have to return. So that would be the base condition. So how we can update this code in order to find the solution? Let us name this find exponent, 2 parameters, base and power. Okay, base and power we have to pass. Now if exponent is 0, in that case simply return 1. Else what we have to do? We have to keep on multiplying base exponent number of times. For that we are applying here recursion. So in that case we'll return base into, call the function again, find exponent for xp, any last value have been considered here or multiplication of base. Now we'll start for one lesser value. Okay, so this star will keep on multiplying till we get 1. Similarly, if we call this function find exponent for 3 to power 2. Okay, so 3 would go to base and 2 would go to exponent. This is the example of required argument. So both the required argument are passed and this result will get. So let us try to run this. Missing one positional argument. I think there should be one more parameter, x minus 1. So base also we need to give here. Now if I run it, it is giving 9. So answer we are getting. So this way we need to think about the logic of the problem and what should be the base condition, and it is just similar to other programming language. We are using def and calling the function inside that function only. According to the question in hand, we need to think on the problem, how we have to terminate, and if it is not the terminating condition, how we have to call the function recursively. Okay, one other problem is also here, like a 4-digit number is entered through a keyboard and we have to write a recursive function to calculate sum of 4 digits of the number. Yani, whatever number of digits are there, all those digits should be added up. Now in this case, what should be the base condition? Base condition is when suppose we take a number 3, 4, 5. So we have to extract one digit. That would be first digit or last digit. If we apply mode of 10, it will give 5. Okay, this 5 we can add into the some variable and then we can start further process on 345 divided by 10. That would be 34. So we keep on reducing this number till we get 0. Okay, so that condition when we are getting after division 0 would be the base condition for this problem. Okay, so what we have to do in this case, we have to find out sum of digits when a number is passed to this function. A number is passed to this function. Now if this number which is passed, that could be 2-digit, 3-digit, or even last value 0. So if that is 0, in that case we'll return 0. Otherwise, what we have to do, we have to find out that last digit. To find out the last digit, we'll do number mod 10 and then last digit has to be added with the next sum of digits. So to find the next sum of digits, we'll call this function recursively sum of digits, and then what we have to pass, not that number exactly, but the next value for number after floor division. So this operator is floor division, that will remove the last digit from the number and will provide the remaining number. For that remaining number, it will call this function. So again, if it is at 0, it will return 0 and it would be added here. Otherwise, one more value from the existing number, last number, would be taken out and would be added up. So if we execute this, for example here, we have to call this sum of digits function with value 3, 4, 5. Okay, whatever value is returned, that should be printed out. So let me execute it. So 12 output we are getting because we passed 3, 4, 5. So 3 plus 4 plus 5 is 12. That is returned by this recursive function. So I hope you can easily implement other such type of problem through recursion, which is very similar to C programming, and just we need to focus on the base condition, limiting condition, and how we have to apply recursion. These are the solutions that we have just discussed, and we'll continue the next topic in the next lecture series. Till then, keep studying. Thank you.